Alright, what's up, y'all? How we doing? Happy Friday. Let's get it. Alright, who am I? I'm Jake. I like windows and cars and a bunch of stuff. And I like the Physical Security Interest Group, which happens to meet on Mondays from 1 to 2 in Golisano 17, 10, 20, and 30. Y'all should show up. Alright, so we're going to try and make things a little quick because it's nice out and I want to go home. So yeah, we got our agenda. Cool, you can read it. All right, so let's talk DLLs, right? We're gonna start with the absolute basics here, just because everyone probably on some slightly different skill levels in terms of their Windows offensive security. So DLLs, that stands for Dynamic Link Library. Basically, they contain a lot of common code within Windows, right? So they're primarily designed to save on space, both on disk and in memory. So basically, why have like 30 copies of the same little bit of code when you could just have one DLLs? So some nice ones, we got NTDLL, we got user 32, we got kernel 32. Those have some fun functions there. You might know them, you might not. But they're just, a very, very small subset of the massive quantity of functions that you could find in DLLs. And also, malware can take the form of a DLL as well. So, yeah, foreshadowing. Oh, and if you've ever seen this message box before, you can thank DLLs for that. Cool. So now let's talk DLL injection. So DLL injection is basically having a program, like a victim process, and injecting an arbitrary DLL into that, right? So it's basically a 4-step process, right? You find the process that you want to inject into. So say explorer.exe, everyone's favorite. Bless you. You allocate memory into that process, right? So it's not a lot, just enough to cover the path of the DLL, which, as you can see in step 3, you're going to be writing the path to that DLL into that buffer that you just allocated. And then the 4th step is to call load library with that buffer as the argument. And what happens is that load library call, assuming you use create remote thread ex, whatever, that gets called in the context of the victim process, and the DLL is loaded into the victim process. Let's go, malware. All right, so reflective code loading. This is the process of loading code from memory instead of loading code from the disk, right? So from the MITRE attack matrix, adversaries, yeah, they can load code, whatever. Concealing the execution of malicious payloads, that's a good one. That's a good line there. And then there's the part that I like. Yeah, creating a threader process, or yeah, Vice creating a threader process backed by a file path on disk. Right, so bypassing the disk, we're reflecting. All right, so now let's take those concepts, those very awesome concepts, and what if we just combine them together, right? So that is what reflective DLL injection is. So it's reflectively loading a DLL into a victim process, right? So make sense, everyone? Yeah? Cool? Cool. All right, so let's talk about usefulness, right? So why are reflective DLLs useful? Well, oh yeah, I put a question here. Does anyone see a flaw here? Something that kind of sucks?
So each module load library A, it takes a file name.
Yeah.
You can just put in any file name,
Uh,
Could you?
well, yeah, you are on the right track there. So basically, yeah, right? So file name. We're reading a DLL from disk, right? That's kind of lame. we want to load a DLL from memory for defense evasion. So defense evasion is basically in the Windows world pretty much just avoiding defender for all intents and purposes. So yeah, basically AV solutions have gotten pretty decent, but there's still a pretty heavy reliance on file system stuff for their signature-based analysis, and yeah. So writing files to disk is a pretty solid way to trigger defender, especially if your payloads will happen to well, get caught by signature-based analysis. So we can just pretty much avoid touching the file system altogether using reflective code loading, so reflective DLL injection. Yeah, that's pretty much that. What was that middle part? Oh, yeah. Yeah, so AV has to, yeah, that I should probably touch on that. So AV has like this fine balancing act of being as secure as possible, right, without really impacting usability. So if you're just like scanning constantly just every single bit of that machine, you're going to make the machine like borderline useless, because it's just going to be scanning the entire time. That's unusable, right? So it's a fine balance of like how many resources do we dedicate to scanning versus, yeah.
When you're talking about scanning, do you mean just like scanning all of the memory, or just the parts of memory that the system knows is being loaded?
It depends on the AV system implementation, but yeah, so it's kind of dependent there. All right, so yeah, basically we're gonna try and go from this, which is my laptop, to this, which is a VM. Yeah, but no threats. We don't want defender to trigger on our payload, because that makes us red teamers sad. So all right. Step 3, we are absolutely cruising at this point. So it says deep dive. It's actually only 2 slides, and it's really not that deep because I don't really want to stand here and talk about code while it's in front of you. So I'm going to talk about the comments in the code. These are directly pulled from the comments, right? So this is, oh, I guess the link doesn't really show up. But there's links in here, so I'll post these slides later, and if anyone's interested, they could click the links. Reflectiveloader.c is in like the most, this is pulled from the most popular reflective DLL repo on GitHub. This is Stephen Fewer's implementation. He's cool. I'll talk about him a little later. But yeah, so basically the step-by-step analysis, right? So step 0, because we start at 0. Cool. We calculate our image's current base address, and that's just so we can use that for future calculations. And then we process the exports for the functions that our loader actually needs to work, right? And so the only functions we actually need are load library, get proc address, virtual alloc, and NT flush instruction cache. I don't know what that last one's for, but yeah. So the other 3 are pretty neat, and those are all just basically used to load the DLL. Funny enough, we're calling load library A, which is kind of what we were bypassing in the first place, but you know, whatever. So yeah, then we step 2, but actually 3. We load our image into a new location, but this is the permanent location where it'll actually be executed from. Then we load in all of the sections. Then we process the image's import table, right? So we're going through the reflective DLL and then loading the DLLs that DLL uses. Fun. And then we process the relocations because, yeah, that's fun. Then we call the image's entry point, which is the DLL main. So step 7, there is no step 7. The comments just go from step 6 to 8. So yeah. And then step 8 is we return our new entry point address, so that whatever called us can call DLL main if needed. Yeah, so if you want more of a deep dive, there's a really great video. I forget who it's by, but it was a really cool talk. And it's like probably about 30 minutes of it is just talking about these 8 steps. So like that might be something to check out. Or if you want a bit more insight, you could look at the actual code. But again, like I said, I'm not really going to stand up here and talk to you about what every line is doing, because that's no. So yeah, so as you can see, start off with step 6 and go to step 8, and yeah, there's no step 7. Yeah, so that's cool. All right, so current use, reflective DLL injection in the modern era, right? So as you can see, there's some pretty interesting stuff that uses it. So first off, we start with Metasploit. Oh yeah, so I said we would talk about this Stephen Fewer guy. He's pretty cool. So he was the one that, like, I don't know if he's the original author of, or the original creator of reflective DLL injection, I guess, in theory. But like, he has like the main repo. It's like the go-to, and that's this guy ended up working for the Metasploit project during the years that he wrote that code, so it has made its way into Metasploit. No surprise there. It's also in Cobalt Strike, or at least it's in the credits page, so I'm assuming it's probably in there. Don't really know, but I'd imagine. Finally, possible RITSec red team tool / framework coming soon, maybe? But unless you're a blue teamer, then no, don't worry about it. Alright, so finally, I think this is the last step. Yeah. So, implementing reflective DLL injection in your own tools, because it's cool. So, nicely enough, there's actually a very nice Visual Studio template for exactly this, and it is part of the Metasploit framework, right? So if you want to call your DLL from, I think you might be able to do it from a Meterpreter shell, which is cool. You just got to compile it from that template. It's kind of hidden in the repo, but it's there. Like I said, there's a link there, but it's, you know, it doesn't do you much good looking at a presentation. And I'm certainly not going to click it right now. So you can also clone the Stephen Fewer repo and then modify that DLL source, as well as, if you really want to, you can play around with the injector source, which I did. One thing worth noting, there is a pull request there that fixes one issue, and I don't know why it worked, but actually I do. But yeah, so a previous version, a value could be null, but then the newer version, the value can't be null, but then over time it got mixed up. Yeah, whatever. So it was a bit painful. Alright, so now we got a little demo prepared. So basically, I wrote some code, I modified, so going back to here, right? Perhaps you can play around with the inject source code, right? So I did that. Basically, I modified the injector so that it finds the Explorer process, it pulls down the DLL, the size of the DLL payload from the server, and then allocates that much memory. It pulls down the actual DLL, and then reflectively loads the DLL, and then we win. Alright, so hypothetically speaking, This is all hypothetical. Right? Yeah. No.
This is not happening.
This is a figment of your imagination. Look at this neat background. Where are we at? Rio. All right. I do. I like the space backgrounds better. Super secure password. Sure some of you could probably guess it. It's password -123. Yeah, no, of course. All right. So we're going to make this extra cool, right? Check this out. Check this out. We got real-time protection on. All right? Normally you go to class and it's like, all right, we're going to disable this real-time protection thing because it just gets in the way. Nah, we're enabling it and hoping Defender hasn't caught wind of my tool in the past day. Yeah. All right. So we have my awesome HTTP file server. We're going to download the exe payload, right? Look at that. It hasn't been flagged yet. Then we're off to a good start. We're going to downloads. I hope not. I would greatly prefer. Here, ready? There you go, Microsoft. Have at it. All right. So we're gonna run it now. All right. So basically, once again, talking through what this does. It injects our malicious payload into Explorer. Right, that's basically it. Except it doesn't write the malicious payload to disk. Right, so the malicious payload. I'm getting lost. Help. Okay, so the malicious payload is here, aptly named DLL.dll. Yeah, good luck catching that, Microsoft. All right, so we're running inject.exe. Right. And it's going to wait 15 seconds because I like the dramatic effect. And it has nothing to do with the really backwards way that I was testing it before that involved disabling my VPN and some funky shit. All right, look at that. So we got, let's see, getting content length. We got it. It's 381,000 bytes. Then we read the bytes. Look at that. That's the MZ header. Anyone that knows how PE files are working means that we successfully got it, probably. Probably, right? So now we attempted to load the library, and we injected the DLL into the Explorer process. What did it do? I don't know. All right.
You wrote it.
So? All right, so if we go over to our lovely C2, shout out to my repo. We hit refresh. Oh, look at that. It went from 0 to 1. How crazy is that? Let's go. Let's go. Let's see here. Let's take a little screenshot here. Hold on. Let's pull something up. Let's
We should get another clap for that web design though.
dude. So lit. Let's go. All right. Nah, we're just gonna take a picture of the real-time protection being enabled.
Oh, let's go.
Let's go. Defender. Nah. All right, we're gonna take a screenshot now. Then we're gonna hit the refresh button. I don't think that registered. We're gonna press it again. All right, it registered for real. Oh, it's gone. Oh, look at that. We go to files. We go. Oh, which one is it? Is it this one? It's got to be this one. Nope, that's the old one. That's the old one. That's a test. No.
It was a misinput.
It was a misinput.
Bro, this is fake.
Let's go. Real-time protection is enabled. Yeah, that's basically it. Any questions? All right, I'm basically the best at explaining things then. Cool. Thank you all.
I just want to say Windows still sucks, but
No, it doesn't. No, it doesn't. Where's Zoom? Where's Zoom? Got it.
Yeah, me when I kick zip